The topic is graphing functions of two variables. So let's start doing the example. Sketch at least 5 label contours for f of xy equal 8 minus 2x squared minus 4y squared. So let's look at the definition. Definition says the contour at z equals c is the set of all order pairs xy such that f of xy is equal c. So for our example, a contour at z equals c is the set of all xy's such that 8 minus 2x squared minus 4y squared is equal some constant c. So let's sketch some contours. So let's pick some values for c. Let's start with c equals 0. If c equals 0, well, before we do that, let me just say, if we solve, see, 8, let me write it here, 8 minus 2x squared minus 4y squared is equal c. This means that negative 2x squared minus 4y squared is equal c minus 8. Now divide by negative 1. You'll get 2x squared plus 4y squared is equal 8 minus c. I mean, the reason why we have to do it that way, since this is positive, now we know that 8 minus c has to be bigger than 0, which means c has to be smaller than 8, right? Alright, well, bigger or equal, right? So this has to be smaller or equal than 8. So this way we know what to pick for c. So we're going to pick c equals 0, 4, 8, and then negative 4, maybe negative 8. Negative 4 would be fine. Alright, so let's start with c equals 0. c equals 0, now I'm going to plug it here. This gives me 2x squared plus 4y squared is equal 8 minus 0 is 8. Now I can think of the ellipse, so divide everything by 8. 2x squared divided by 8 plus 4y squared divided by 8. 8 divided by 8 is 1. Now divide by 2. So in other words, reduce 2 over 8. 2 over 8 is the same thing as 1 over 4. Right, divide by 2, yep. And then reduce 4 over 8, they're going to give you 1/2. So that will be 2. Right, in other words, this is the same thing as x squared over 2 squared plus y squared over square root of 2 squared equal 1. Now looking at the ellipse right here, my a happens to be 2 and my b happens to be square root of 2. So I'm going to go here. This is 2, negative 2. Square root of 2 is 1.41. So square root of 2, negative square root of 2. And then I can draw my first ellipse. So c equal 0. Now what about c equal 4? c equal 4 means that 2x squared plus 4y squared is equal 4 minus 8. I'm plugging 4 here. 8 minus 4 is equal 4. Now divide by 4. 2x squared over 4 plus 4y squared over 4 equal 1. Again, reduce 2 over 4. We'll get x squared over 2. But 2 is the same thing as square root of 2 squared. Plus 4 over 4 is just 1. And 1 is just 1 squared. Equal 1. So my a happens to be, so it's another ellipse, right? Make sure I have to write an ellipse. Another ellipse. So my a is square root of 2, my b is 1. So square root of 2 something is not right. No? No, that's right. That's right. Square root of 2 will be here. Negative square root of 2 will be there. And then 1, negative 1. So it's going to be this one. So this is going to be c equal 4. Now what about c equal 8? C equal 8 will give us 2x squared plus 4y squared. Now I need to plug the 8 right here. 8 minus 8 will give me 0. The only way for this to be 0, x and y has to be 0. So we get the point 0, 0. So we'll get this point. So this is going to be c equal 8. Now let's do at least one negative number. C equal negative 4. 2x squared plus 4y squared is equal, again, 8 minus 4, minus 4 is 12. Now divide by 12. To get a 1. Right? The reason why we divide by 12, we always want to have a 1 because the ellipse, you get a 1 on the right side. Now, reduce 2 over 12. 2 over 12, if you reduce it, you get 1 over 6. So 6 is the same thing as square root of 6 squared. Plus, reduce 4 over 12, you'll get 1 over 3. But 3 is the same thing as square root of 3 squared. So my a happens to be square root of 6. My b happens to be square root of 3. What is square root of 6? Let's use a calculator. Square root of 6 is 2.44. So kind of like here. So it's square root of 6. Negative square root of 6. And square root of 3 is 1.73, which is here. So we get another ellipse here. So you can tell the ellipses are getting closer and closer to each other. So to describe the contours are ellipses, well, concentric, right? What else? They are getting packed as they getting further from the origin. Or they are getting packed as we move away from the origin. Alright, now let's move on to question C. Graph the cross section of f at y equals 0, and I'm looking at the definition. So the cross section means whatever I see, well, definition at y equals 0 will be right here, this one. So it will be c equal, or f of x 0, which is equal what? So z is equal f of x 0, which is equal whatever you see while you plug a 0, so that would be 8 minus 2x squared minus 4 times 0 squared. So it's going to be z equal 8 minus 2x squared. Right, so that's a parabola, right? I mean, the origin of 8, so there is an 8, and it's gonna face down. Right, question D, need to find the cross section at x equals 0, and that's z equal, definition is right here, f of 0 y. So whatever I see a y I plug 0, that would be 8 minus 2x squared minus 4 times z squared. All I did, I need to plug a 0 for x, so this will be 0 and this is stay y. So z will be equal 8 minus 4y squared. That's also a parabola. Eight is the vertex, 0, 8. Alright, now for next question, use the contour along with the graphs of the cross section to graph f of x, y. So of course we have for the z-axis is 8. We know that on the z, let's start with the zy plane. On the zy plane, which one is larger? The ellipses are larger along the x-axis, right? So we want to make sure we do that. So along the z, on the zx plane, we're gonna get that trace, right? I'm doing this first. Now on the zy plane, getting something like that, and then using the contours, we're gonna get those ellipses. Here are the ellipses. In other words, the graph would look more like so elliptical paraboloid. So that's not circular one, elliptical paraboloid. And that's it for this example.